Hello everyone, I'm Dr. Chander Pawar, working as an assistant professor in the Department of Chemistry at VJEC, Hyderabad. Today, briefly, I will be discussing about self-healing materials and their applications, definition of self-healing materials, and the mechanism of self-healing material, and some of the examples and challenges associated with these self-healing materials, followed by their industrial as well other domestic applications and all. Okay, so basically, as we know that skin is one of the best example for this self-healing material. Whenever there is a cut or scar kind of thing on the our biological system body, especially when we talk about skin, so it will heal automatically. We need not have to, if the based on the injury, if the injury is very much severe, then we have to go doctor and we have to get some medication and all. But if it is small scratch or cut kind of thing, so over a period of time that will automatically heals. That's what here biomimicry is much more correlated with the self-healing materials. As it is mentioned here, they are designed to mimic biological systems like how human skin heals after injury and restore their original properties to extend the material's lifetime. Yes, absolutely. So this kind of self-healing mechanism, how the skin is mimicking biological system to repair itself. So that kind of materials we are calling it as a self-healing materials. For example, if there is a defect or manufacturing defect or anything deformation or crack, scratch or void or pit or any kind of defects, so material should be integrated with the kind of material which stimulates and heal autonomously. Okay, that's the property we are discussing today, and we can see here car with the dent and scratches, and if we integrate the whatever the painted surface with those kind of stimulating factors, then the scratch or that damage can be automatically healed. Here we can see as blood wherever there is a cut, basically what will happen over a period of time, there will be a collagen formation, fibrin mesh formation, and then automatically the bleeding will stops. How it is happening? Basically activation of that biological system which is already integrated with our blood and other systems. So likewise we have to come up with a self-healing material which can heal itself the damage or crack whatever it is there. So here we can see here pictorial representation. There is a microcapsule and there is a damage. So this microcapsule will be activated, and then whatever the crack or scratch will be there, that will be healed automatically in a material perspective rather than the biological system. Okay. Now here we can see there is a huge pictorial representation of this scratch or something damage to a material, and how this biological system is mimicking to overcome this kind of damages or scratches and all, followed by the smart materials. Okay, as we can call these smart material self-healing materials as a smart material. Smart is nothing but the word smart defines as responsiveness. Okay, so responsiveness is nothing but the smart or intelligent material we can call. So these self-healing materials are a kind of intelligent materials. How they are intelligent? Because they are engineered in such a way that to mimic the biological system, and especially how the human skin works. Okay, and the core ability to automatically repair damage and such as cracks and scratches, dents or other white space, minute hairy cracks and all, pits and all will be healed themselves. And that is the beauty of these smart self-healing materials. And the key differentiators is this process occurs without external human interventions. Yes, absolutely. As we are calling these self-healing materials as a smart materials, there is no need of any human intervention or tuning something. Automatically, when is there is a damage or a crack or anything abnormal, then the automatically whatever the integrated system is there, that has to stimulate and repair itself. Okay. Now, these self-healing materials are broadly categorized into two types: extrinsic self-healing material, intrinsic self-healing material. Okay, these extrinsic self-healing materials are embedded healing agents like microcapsules, hollow fibers, vascular network, etc., and which can help us to heal that damage or any kind of abnormal thing in the material. Another type of self-healing material mechanism is intrinsic self-healing mechanism, and this is basically happens because of the chemical bonds or physical interactions like hydrogen bonding, van der Waals forces, dipole-dipole interactions, electrostatic interactions. Apart from that, disulfide metathesis and atom economy reaction like Diels-Alder reaction, etc., sometimes ionic interactions, covalent interactions and all, and this is a kind of physical and chemical bonding or packaging or repair mechanism. Okay, and here we can see the exact meaning of these two words as self-healing mechanisms. Extrinsic healing agent will be released from that, and intrinsic a bond reversibility, it could be chemically or it could be physically to repair the damage. Now we can see, as we are talking about the biomimicry, and human skin is one of the best example for this correlate this smart self-healing materials. We can see the word hemostasis is a blueprint for the biological system. Hemostasis is nothing but which can stop the blood flow. So basically here we can see a damaged vessel pictorial representation, and how this blood red RBCs and all coming out. But over a period of time, what will happen, there will three steps in that. A broken blood vessel triggers the release of repair agents, followed by the platelet activation and aggregates at the site or that blocked or cut vessel, and then a fibrin mesh formation followed by the sealing that blood circulation. Okay, blood release. Now we can see the beauty. We can see here there is a complex network system. What's happening, as it is mentioned here, platelet activations followed by the release of thrombins, prothrombins, and then it will lead to the fibronectin and fibrin mesh, collagen kind of mesh formation. With that, this network will be stopping the flow of the blood, and that is how our smart healing material has to be activated, and it should repair itself. Now the mechanism we can see here, the embedded system, basically the paint or whatever we are talking about the material, so that should be embedded or integrated with this kind of micro capsules, and whenever there is a damage, this microcapsule will be stimulated, and it has to be filled that gap or damage or wide space or minute hairy cracks. With that, solidification will takes place, and finally that damage will be repaired. Now let us try to understand here from this. There is a material matrix, and then embedded microcapsule, integrated microcapsule into that material matrix. And just as the body has platelet waiting in the bloodstream, self-healing materials contain healing agents integrated within the material matrix, and then microcapsules containing a healing agent that will be initially dormant means inactive, but whenever the damage is there, then that whatever this bluish microcapsule portion is there, that will be activated. But if there is no any damage, then that microcapsule whatever is integrated or embedded into that material, that will be in the dormant state, and that will, based on the damage, it will be activated to fulfill those gaps or damages. We can see here the material, this is bluish one is the material, and integrated capsule. Here we can see whenever there is a crack, okay, across that microcapsule, this is a microcapsule and this is the material matrix, okay, and based on that crack, this microcapsule has been activated or releasing that, it has been stimulated based on this damage, and it is releasing whatever the content is there, and then finally that content will helping us to fulfill these gaps. Okay, I hope this image is explaining very nicely how this is working. Okay, and then it is like a polymerization and restoration mechanism. We can see here the released agent fills the void and solidifies bonding material back together. Yes, we can see here this yellowish portion, and this bluish one represents the damage. Yellowish portion, that is the microcapsule activation, followed by release of whatever the material is there in that. It could be polymer, polyurethane especially one of the best example for the self-healing material. So here we can see that activation of microcapsule and filling that damaged portion, and finally solidified part in this material. Okay, so this mimics the fibrin mesh in biology, turning a liquid response into a solid seal. We can see here solidified and then finally smooth finishing into that material. The material returns to a healed state and preventing catastrophic failures or damages. Okay, now again we can see here a vessel, the comparison biological system with the engineering. Okay, so broken vessel, what will happen? Blood flows and then platelet activation, and then followed by the a network, fibrin mesh network formation. That network will hinder the flow or coming out the blood cells out, and then finally that will help us to stop the blood bleeding. Okay, now similarly you can see here there is a material with crack, and then the microcapsules are integrated in that material, and then whenever there is a damage or crack or any kind of abnormal issues with that material, then the microcapsule, the dormant microcapsule, inactive microcapsules will be activated, and that material will be released, and then finally the gap or damage will be fulfilled, and finally that material will be appearing and ready to usage. Here we can see a car with scratch or kind of damage, and then how that self-healing material, especially smart self-healing material, so how it is helping to repair it, so damage or scratches itself. If we come up this kind of technology, that will be really helpful for many sectors, not only in the automobile engineering and automobile sector. It will be helpful for many industrial and as well any other buildings and civil department and all. Okay, now we can see that by designing material that mimic the resilience of human skin, we move from a paradigm of break and replace to a damage and heal. Such a wonderful definition. So the self-healing materials represent a next generation of smart autonomous infrastructure which can be helping us to repair the biological system. Not only the engineering perspective, it can help us in biological way to treat the diseases or many other aspects. Okay, now the major applications of smart materials is hydrogel for biomedical usage, and for the concrete self-healing concrete to avoid the damage or cracks, and then the carbon fiber composites, shape memory alloys, metals and alloys, ceramics, coatings. All these are the some of the applications of these smart self-healing materials. And certainly there are some limitations: trade-off in properties, scalability and cost, durability under diverse conditions, limited multiple healing cycles. Yeah, sometimes if that whatever the micro capsule is there, if it is used and if there is a second time crack, then that micro capsule may not be helping us to heal. So that is the major hurdle or limitation over here. So certainly there are some benefits from this smart self-healing materials: reduced maintenance and low cost, sometimes improved safety, extended lifespan of that particular material, and environmental sustainability. When we talk about the future directions and innovations of these materials, self-healing materials, multifunctional materials, advanced characterization techniques, bio-inspired designs like implants, and energy storage applications. Apart from that, aerospace, construction field, electronics, automotive, as I said, biomedical, surgical implants, and energy storage applications. These are wide applications of these smart materials. Okay, these are the contents, sources of AI tools like DeepSeek, ChatGPT, Agentic AI, and other research articles. And we can see here a smart nanoball which is made during my research tenure, and which is published already in this Chemistry Select journal. So in another video we will meet with another interesting topic. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.